Welcome to all. In this particular video, we will see the concept of binary subtraction. So in the previous session, we have seen the concept of addition along with the carry concept. But here, when we are dealing with the subtraction, it is little bit different from the previous step. Okay, binary subtraction is one of the four binary operations where we perform subtraction method for two binary numbers comprising of only two digits 0 and 1. So ultimately why we are taking only 0 and 1, because it is a binary. So binary stands for either 0 or 1. This operation is similar to the basic arithmetic subtraction performed on a decimal number in maths. So it is almost same, but with respect to zeros and ones, how we are going to deal with the problem, that is the actual thing. Okay, hence when we subtract 1 from 0, we need to borrow 1 from the next higher order digit to reduce the digit by 1, and the remainder left is also 1. So it is a general form, isn't it? When you are trying to subtract a number which is greater than the actual number, then definitely you are going to take the you are going to borrow the number from the left hand side, isn't it? Usually you do that, correct? So if the number is small, instead of going for minus values, you usually go for taking the or borrowing the number from the left hand side. In the same concept is applied here also. There is nothing big deal, but how exactly we are going to do, we will see in the next slide. Okay, so here see, you have to see for the binary subtraction there are some concept which you have to remember. So 0 minus 0 is obviously 0, 1 minus 0 is 1, 1 minus 1 is 0, but when it comes for 0 minus 1, so answer is 1 along with the borrow. Okay, so in the addition, you have seen the concept of carry, but in case of subtraction, you are seeing the concept of borrow. So you are borrowing one more number from the left hand side. Okay, so we will see, while solving the problem you are going to get the better idea. Okay, so subtraction of binary number is an arithmetic operation similar to the subtraction to the decimal number, whatever the base 10, you are going to do the same thing. So for example, 1 plus 1 plus 1 is equal to 3 in the base 10, and 1 plus 1 plus 1 equal to 1 1 in binary system, isn't it? How 1 plus 1 plus 1 is equal to 1 1? It is not 11. Please don't confuse, it is not 11. In terms of binary system, it is not 11. Why? Because 3, how to represent 3 using 2 bits? It is 1 1, isn't it? 2 to the power 0 and 2 to the power 1. 2 to the power 0 is nothing but 1, and 2 to the power 1 is nothing but 2. 2 plus 1, 3. Total 3. Did you understand how exactly you are thinking about the binary system? There is no rocket science. Don't consider it as 11. It is not 11. It is 1 1. 1 plus 1 plus 1 equal to 1 1 with respect to binary number system. But with respect to decimal number system, it is 3. When you add and subtract binary numbers, you will need to be careful when borrowing, as these will take place more often. So yeah, while taking the borrowing things, you should be very careful, because it is a kind of confusing one. So don't get confused while solving the problem. You don't you will clear all these doubts, but don't worry. But this is the thing you have to remember. As a theoretical part, I'm saying this, you have to remember this. Okay, when you subtract several columns of binary digits, you must take into account the borrowing. While taking the borrowing, you should be very careful. In terms of carry also, you should be careful, but while doing the subtraction concept, this borrowing concept is very careful. You should be very careful. When 1 is to be subtracted from 0, the result is 1, where 1 is borrowed from the next higher order bit or digit. That is the reason. So I said from left hand side, but they are in a little bit standard. They use some standard concept for this. Okay, so while solving, we will get to know. Fine. So see, this is the example. So here in this example, what we are going to do, we are going to subtract 1 0 1 0 and you are going to subtract 1 0 1 from 1 0 1 0. So what is 1 0 1 0? It is nothing but 2 to the power 0 2 4 8 8 plus 2 10 10 minus 2 4 4 5 10 minus 5, isn't it? That is 10 minus 5, isn't it? Correct. So first step is first consider the ones column and subtract the ones column 0 minus 1, then and it gives the result 1 as per the condition of binary subtraction with a borrow of 1 from 1 zeros place. It is not tens place, 1 zeros place. Okay. Step 2, after borrowed one of the 1 zeros column, the value 1 in the 1 zeros column is changed into 0. Now how exactly we are going to do, we will say. Now see, you can see it is 1010 and we are subtracting 101, isn't it? 0 minus 1, what you have to do, you have to take one borrow from the left hand side, isn't it? So you are going to make your left hand side 0 and you are bringing that 1 to the right hand side. Now that becomes 2, isn't it? When you bring some value from right hand side, it becomes left hand side, it becomes 2. 2 minus 1 is nothing but 1. Fine. Now you have 0 and rest all are 0. So ultimately you are going to get the value as 0 0 0 1. They have written only 1 over there, but the total actual concept is 0 0 0 1. You are going to get the output as 0 0 0 1. In step 3, the subtract the value in 1 zeros place. 0 0 equal to 0. 0 minus 0 equal to 0. So ultimately that is stepwise step they have given. See, next step is already it was 0. So 0 minus 0 is nothing but 0. In the third step, what they are going to do? They are going to do 0 minus 1 which is nothing but actually 1. Isn't it? So you can see here where it is. Yeah, in step 4. So now subtract the values in 100's place. So borrow 1 from the 1000's place. So that is nothing but 0 minus 1 is 1. So you are going to get as 1, and at the end 1 minus 1 is nothing but 0. So ultimately the value will be 0 1 0 1, isn't it? So what is 0 1 0 1? It is 4 plus 1, 5, isn't it? So that is the reason why I said 10 minus 5 is 5. So ultimately you are going to get the value as 5. The resultant of the subtract operation is 0 1 0 1. You can cross check the binary subtraction resultant as well by converting that the result to the binary system, decimal system, so that you are going to get the actual number. Now let me say again, if you are having any doubt, let me say again. So what you are going to do, see, you have to remember this part. This part, you have to remember this part. 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 0 minus 1 is 1 with the borrow. You are going to bring one more value from left hand side. If left hand side also 0, then again you are checking for the one more left hand side, isn't it? So that's why in standard format what they have they said, so it is borrowed from next highest order bit or digit. That is the better sentence they can make. Instead of saying left left left, it is better to say that borrowed from next highest order bit. That is nothing but from left hand side itself, because all these binary operation has to be considered from right hand side for the better purpose or for the better calculation. Okay, now directly you can concentrate on this example. So it is something like 1010 minus 101. Now in the first option, 0 minus 1 is, 0 minus 1 is 1, but along with the borrow, isn't it? You have to go for borrow. So when you have borrowed 1 from your left hand side, that becomes 0, isn't it? Correct? So 0 minus 0 is 0. Now again 0 minus 1 is 1, and 1 minus 1 is, it's 0, because you had one borrow, isn't it? That's why that becomes 0. Fine. So you can think of this. You can see the step. If you want to go for step by step, that also fine. So in the first step, you are just going for the borrow concept. In the second step, you are actually considering the second order or second position. So after borrowing, what happens for 1 0? Next, the third step, what you are going to do, you are considering the zeroth place. Zeroth place is nothing but after borrowing, your left hand side becomes 0. That's why 0 minus 0 becomes 0. The result they have written 0 and 1. Next, in the fourth step, what they are going to do, they are going to consider the rest of the places. So it is nothing but borrow followed by your number. Correct? So it is something like 0 minus 1, 0 minus 0, 0 minus 1 and 1 minus 1. Now you may ask from where that 1 came. So 1 is nothing but that borrow. You have already taken the borrow, isn't it? You have to consider that borrow also. You cannot neglect the borrow. That's why in the initial stage only they said, while calculating about the borrow, you should be very careful. Fine. So if it is confusing for you, I will make one more video where I will write it in a note and then I will upload. But if you understood, it is well and good. There is nothing big deal here. You have to just consider you have to just concentrate on this binary subtraction table. Based on this table only, that will work. Your subtraction will work. Fine. So now so instead of going for 1's complement and all, I will just skip this because I want to know whether you have understood that subtraction or not. So you try out this subtraction concept. If you get any doubt, you can get back to me. Otherwise, I will solve manually in a sheet of paper and I will upload that image to. I will make one video of that image only so that you can get the better idea. Fine. Now for time being, I just skip this binary 1's complement and 2's complement. So there are some examples. Directly I come to 9's complement subtraction steps. It is somewhat different from the previous thing. Don't worry. Fine. Now see, there are some concepts of 9's complement and 10's complement. So far you have seen 1's complement and 2's complement long back. Now the concept is 9's complement and 10's complement. So we will see what is 9's complement. Okay, with the help of 9's complement, the process of subtraction is done in a much easier way. Generally, we subtract the subtrahend from the minuend, but in a case when we perform subtraction using 9's complement, there is no need to do the same. Okay, so the subtraction to numbers using 9's complement, we first have to find the 9's complement of the subtrahend, and then we will add this complement value with the minuend. Okay, now there are two possible cases when we subtract the numbers using 9's complement. So there are two cases actually when we deal with the 9's complement. So I will say how exactly 9's complement works, okay, along with the example in the next slide, don't worry. But the first case is when the subtrahend is smaller than the minuend. That is nothing but if the value is smaller, something like if you are going to get the minus values. Okay, how exactly you have to deal with the 9's complement, that also along with the positive value always and along with the negative value. There are two actual cases. Okay, for subtracting the smaller number from the larger number using 9's complement, we will find 9's complement of the subtrahend and then we add this complement value with the minuend. By adding both of these, the result will come in a formation of carry. At last, we will add this carry to the result obtained previously. This is a theoretical part. When you solve the problem, you are going to get the rough idea. Okay, don't worry. In the next step, I will show you. Okay, so this is the example. See, the general example is, they have taken one general example, 841 minus 329. Okay, so in general form, what you have to do, you are subtracting 329 from 841. You are going to get the value as 512. In the left hand side, you can see there. But when you are using 9's complement for subtraction, what you have to do, see, this is when subtrahend is smaller than minuend. Correct? Here subtrahend is smaller. 329 is smaller than 841 minuend, isn't it? So here see 841. Now see, you can see there is a separate little the number has changed. How exactly they have changed, I will explain. But 841 you have to keep as it is. Minuend you have to keep as it is. You have to convert your subtrahend to 9's complement. Now how to convert subtrahend to 9's complement? See, 329 becomes 670. How they have done? The concept is very similar, very same actually. You don't need to worry much. Here, each and every value, 3 is a separate value, 2 is a separate value, 9 is a separate value. Each and every position has to be subtracted by 9. Now, 9 minus 3, how much? 6. 9 minus 2, 7. 9 minus 9, 0. That is the reason why you are going to get 670 or 670. Instead of saying 670, it is better to say 670. Did you understand how they have converted, how they have got 9's complement? This is how you go for 9's complement. How to get 9's complement? You are taking each and every position separately and you are subtracting that position with 9. Understood? 329, how they have got 670? It is something like 9 minus 3, 6. 9 minus 2, 7. 9 minus 9, 0. That is the reason why they have gone for 670. Now you have to add up your minuend and subtrahend, the new subtrahend, isn't it? That is not the old subtrahend. This is a new subtrahend. In the right hand side you can see. Now 1 plus 0, 1. 7 plus 4, it is 11, isn't it? 7 plus 4 is 11, so 1. Now 8 plus 6, how much? 8 plus 6, 14. 14 plus 1, 15, 5 and 1. So total how much you got? You got 1511. Actual value is 1511, but as your subtrahend and minuend is 3 digit or 3 position value, you have to consider the leftmost position as a carry. Fine, it is a carry. Now whenever you get that carry, what you have to do? You have to keep the carry, you have to add up the carry to the 3 positions. Like that is nothing but 511. 511 plus 1 is 512. You are going to get the value as 512. I will explain again. So in the left hand side, you can concentrate on left hand side. 841 minus 329, actual value is 512. This is a normal subtraction. In general mathematics you do the same thing, but in case of 9's complement, subtract using 9's complement. If the case is like subtraction using 9's complement, what you have to do? You have to keep your minuend as it is, and you have to concentrate on subtrahend, because when subtrahend is smaller, it's everything about subtrahend itself. We are mainly concentrating on subtrahend, not minuend in 9's complement here in this example. Fine. Now subtrahend is 329. You have to get the 9's complement of 329. How to get 9's complement of 329? It is nothing but each and every position has to be subtracted with the 9. Fine. So it is nothing but 9 minus 3, 6. 9 minus 2, 7. 9 minus 9, 0. That's why the new subtrahend is 670 or 670. Now you have to add minuend and subtrahend. You are going to get the value as 1511. 1511. Now as the subtrahend and minuend is 3 position value or 3 elements, so you have to consider only 511. Now the carry has to be added with the result. So 511 plus 1, because carry is 1, isn't it? Separate extra value is 1. You have to add that extra value to the result, main result. So you are going to get the value as 512. So you can cross check whenever you solve in the examination, or whenever you solve some examples, you can cross check directly. You go for general subtraction and check for 9's complement subtraction also. It should be same. Otherwise you have to believe that somewhere you have made a mistake. Understood? So this is one part. This is one case. The case 2 is when the subtrahend is greater than minuend. How to deal with that concept? Okay, so you can concentrate on this example. When subtrahend is greater than minuend, what you have to do? General subtraction is, see, 841 is subtracted with 983, isn't it? 983. Answer has to be minus 142. Fine. Now again you are concentrating on subtrahend itself. Don't go for mini-end. Don't touch the mini-end. Only subtrahend. Now you have to convert your subtrahend to 9's complement. So again the same way, 9 minus 9 is 0. 9 minus 8 is 1. 9 minus 3 is 6. So new subtrahend is 0, 1, 6. So what you are going to do, even though it is subtraction, but still once you get the 9's complement, you have to add up with the mini-end. 841 plus 0, 1, 6. That is a normal addition. 1 plus 6 is 7. 4 plus 1 is 5. 8 plus 0 is 8. 857. You are going to get the result as 857. Fine. Now once you get the 857, there is no carry. You don't have the concept of carry. What you have to do, you have to convert your result again to 9's complement. When you don't have the concept of carry, whatever the result you get, you have to convert it to 9's complement again. Remember, if you have the carry, you have to add up the carry to the last three positions. If the subtrahend and mini-end is 3 position values, then you have to go for you have to add up the extra carry to the last 3 positions. If you don't have the carry, what you have to do, whatever the result you get, you have to convert it to 9's complement. How to convert it to 9's complement? Again the same methodology. You are not changing anything. 9 minus 8 1, 9 minus 5 4, 9 minus 7 2. But as no carry, by default you have to put minus symbol because it is a negative number. Always remember, if you don't have the carry, if you don't get the carry, it is by default a negative number. If you get the carry, you have to consider that carry and you have to add that carry to the last 3 positions in case of this example. Now try out 4 position values, something like 1023 plus, say for example 1100. You can do that, or else you can go for 1023 plus just go for 38. See what is the value you are going to get. How to solve it. Just try 1024 plus 38. Okay. Ultimately, to cross check, what you have to do, you have to go for general subtraction and you have to cross check. These are the 2 possible cases with respect to 9's complement, subtraction using 9's complement. Okay. Try out some examples. If you have any doubt, you can get back to me. And when you talk about, there is one more concept of 10's complement. There is a new concept here. So this is slightly changed. No rocket science again. There is a slight change. Once you understood 9's complement, 10's complement is nothing. So subtraction using 10's complement you are going to do in the next part. Okay. Excuse me. The 10's complement is also used to find the subtraction of decimal numbers. Okay, the 10's complement of a number is calculated by subtracting each digit by 9 and then adding 1 to the result. What is the meaning? Subtracting each digit by 1, each digit by 9. That is nothing but getting the 9's complement, isn't it? Each and every position is subtracted by 9. That means to get the 9's complement, first you have to do, to get the 10's complement, first you have to do 9's complement, then you have to add up one more value to that answer. Isn't it? So we will see with the example, don't worry. Now, simply by adding 1 to the 9's complement, we can get 10's complement value. For example, suppose we have a number 1423. Okay. And we want to find 10's complement of this number. What we have to do? We have to find the 9's complement of that number. How to get the 9's complement? It is that is an actual concept they have given with respect to equation itself. But you can go for digit wise digit or position wise position. 9 minus 1, 8. 9 minus 4, 5. 9 minus 2, 7. 9 minus 3, 6. So the 9's complement of 1423 is 8576 or 8576. And now we have to add 1 to that result. So you are going to get the value as 8577. This is the 10's complement of what number? It is a 10's complement of 1423. 8577 is the 10's complement of 1423. We will see the cases also. In tens complement also we have cases. See, subtraction using tens complement. How exactly we are going to do? So there are some theoretical concepts they have given. For subtracting two numbers using tens complement, we first have to find the tens complement of the subtrahend, and then we have to add this complement value to minuend. There are two possible cases here also. The first one is subtrahend is smaller and minuend is greater, and second case is subtrahend is greater than minuend. The same concept, 9's complement, whatever the cases you have seen, the same concept is for 10's complement also, but here a slight difference or slight change can be observed. Okay, now we will see the example itself. Directly we can jump to the example. So you can see this example. So what is the general subtraction? 325 minus 641. Now here subtrahend is smaller than minuend, isn't it? Correct. So here subtrahend is smaller than minuend. Here in this case, what you are going to do? So here 5 minus in the general subtraction you are going to get as minus 316, isn't it? But using tens complement, how to do? So you have to keep the minuend as it is. You are not touching that minuend, but subtrahend you are going to get the tens complement. How to get the tens complement? First you have to convert your 641 to 9's complement. That is nothing but 9 minus 6 3, 9 minus 4 5, 9 minus 1 is 8. Now that is the actual value. 358 is the 9's complement. To get the 10's complement you have to add one more. So 358 plus 1 is 359. So you are going to get the new subtrahend as 359. Isn't it? Now what you are going to do? You are going for actual addition. No special cases over there. So 5 plus 9 is 14. 4, 1 extra 1. So 5 plus 2 is 7 plus 1 8. 3 plus 3 is 6. So 684 you are going to get the result. Now you don't have the concept of carry in this case. What you have to do? You have to convert your 684 to 10's complement. How to do that? First you have to convert your 684 to 9's complement, then you have to add 1, isn't it? So now 9 minus 6 is 3, 9 minus 8 is 1, 9 minus 4 is how much? 5. So 315 you are going to get as a 9's complement. So you have to add up one more value to that value. So you are going to get 316. As you don't have the concept of carry, by default you put minus over there. Remember always, if there is no concept of carry in this 9's complement and 10's complement, by default you have to put minus in front of the result. Fine. The second concept is when subtrahend is small. There is actually spelling mistake. When subtrahend is greater than minuend in the left hand side. In the right hand side, when the subtrahend is smaller than minuend. Fine. So here the general subtraction you can see 821 minus 413. What is the answer you are going to get? You are going to get the value as 408. Isn't it? So now here the subtraction using 10's complement, what you have to do? First you have to convert your 413 to 10's complement. How to do that? First you have to do 9's complement. 9 minus 4 is 5, 9 minus 1 is 8, 9 minus 3 is 6. Isn't it? So 586 you are going to get. So actually there is a mistake. You have to change here. It's a mistake because 10's complement means you have to add the value, isn't it? You have to add up the value. One more value is required. So there is a actual spelling mistake over here. You have to consider it as 587, not 586. Okay. See, you can to check that. See, 6 plus 1 is not 8; it is 7, isn't it? So they have made they have made one mistake over there. You have to consider it. So 586 as a 9's complement. You have to add one more. So the answer is 587. Not 586, 587. So 587 is added up with 1 is 821 plus 587 is 1408. isn't it? Because 7 plus 1 is 8, 8 plus 2 is 10, 0 and 1, 8 plus 5 is 13, 13 plus 1 is 14. Now you are going to get one more carry, isn't it? You are going to get the carry, but in this case you have to ignore the carry. You are not adding up. See, for 9's complement you are going to add the carry, but in 10's complement you are ignoring the carry. Remember this. Fine. You are not adding up the carry in this case in 10's complement. Okay, so you have to ignore the carry. You can see that second case over there. In this case, when we add the complement value to the minuend, the result will not come in the formation of carry. This indicates that number is negative, and for finding for final result we have to add 10's complement of the result obtained by adding the complement of subtrahend and minuend. This is a case of for the negative values. For the positive value, the theoretical concept they have given here. So in the last line you can see we ignore this carry and the remaining digit will be the answer. This is for this example when subtrahend is smaller than minuend. But when subtrahend is greater than minuend, you have the concept of negative. So you are doing the same example, so same explanation whatever I have given, you can think of it. So I request everyone to solve this problem. So you can, if you have any doubt with respect to binary subtraction, I will in next video I will make a separate table, or I will manually solve. I will take the picture and I will post it on. I will make a video on that. Don't worry. But you can. This is 9's complement and 10's complement. There is no problem to you. Already I have explained. Try to solve some more problems on these. Okay, so I will wind up here. I will stop this video here. In the next video we will see the upcoming concepts. Don't worry. Fine, but you have to solve these problems, and if you get any doubt, just get back to me. Don't worry. Fine. Okay, so thanks for watching.